What's up guys, welcome back to the channel. So in our last video, we started setting up our internal SSL and covered the basic of PKI. We also got our internal certificate authority up and running, and that video was part 1 of phase 1. Link of that video is in the description below. It is very important that you watch that video before you watch this video. So please check it out. Link is in the description box below. In this video, which is part 2 of phase 1, we're shifting focus to the server side. So we're going to go through how to generate the private key for the server. We're also going to talk about how to create the CSR, which is certificate sign-in request. We'll talk about that in detail in a minute. We're also going to understand where the public and the private key comes into play. We're also going to use our internal CA that we created in our last video to sign the CSR that we generate on the server side. And then finally, we're going to install the signed certificate on both the server and the client machine so that communication between them is secure and encrypted. Chapters are listed below as always, so please feel free to skip to the part that interests you the most. With that being said, let's go ahead, let's get started. Before we get started, let's take a moment to understand a few things. And first on the list is CSR, which is Certificate Sign-in Request. You'll hear this term a lot when dealing with SSL certificate, and it's important to know what it is, why it's needed, and what it actually does. A CSR, or Certificate Sign-in Request, is a file you generate on the server that contains your public key and some identity information about your server. So things like your domain and your organization. It's also digitally signed using your private key, which proves to the certificate authority that you actually own the matching private key. The CA uses this signature to verify ownership before it agrees to sign and issue a trusted certificate. It's basically your server saying to the certificate authority that, hey, here's who I am, and here's my public key, and I can prove I own it. Let's quickly talk about two types of certificate that you might request when generating a CSR. You have the application-specific certificate, and then you have something like a wildcard certificate. An application-specific certificate is for one exact server or servers. So let's assume that you're setting up something like Vault or something like Proxmox. So the FQDN, or the fully qualified domain name, would be something like vault.example.com or proxmox.example.com. The certificate that you generate will only work for that specific host name or for that specific service. You can add additional server name using something called the SAN field, which stands for Subject Alternative Name. This allows one certificate to cover multiple FQDN all in one single certificate. But there is a trade-off. First, you will need to regenerate the certificate every time you add a new service because you will need to add the FQDN of that service in your SANs. Second, you will be using one private key across multiple servers, which isn't ideal from a security standpoint, but the same issue applies to wildcard certificate as well. So that's something to keep in mind. A wildcard certificate, on the other hand, is much more flexible. It covers any subdomain under your domain. So something like, let's say, vote.example.com, proxmox.example.com, grafana.example.com, or any other application that you're going to set up will be covered through a wildcard certificate. The key difference is that a wildcard certificate covers many services with just one cert, while an application-specific certificate is tied to just one. Nonetheless, you manually expand it with SANs, which are the subject alternative name. Which one you want to set up depends on how your environment is set up or how you want to set up your environment. In my case, for this test environment, I'm going to be generating a wildcard certificate. Now that we have a really good understanding on things, let's go ahead, let's get started on setting things up. All right, so to demo the whole process, I have set up one server and two client VMs. So this is the main server. I've set up a Proxmox server. So this is what we're going to use to generate our private key, generate our CSR, and be able to create a certificate for the server, or in our case, we're creating a wildcard certificate for the whole domain, and be able to apply it to the server and be able to get SSL up and running for the server. So when we access the server, the GUI of the Proxmox server, we're able to make sure that connection is secure. So I've set up the Proxmox server. It's going to act as the main server, and then I've set up two other VMs. So I have my Docker test VM here that I'm using. It's Windows, so I figured I'm going to try to do it on Windows as well to try to see how we can push the certs on Windows. And then I also have set up another VM, which is a Pop OS VM, which is a Linux VM. we're going to push the start on this one as well. So that's kind of the three servers that we're going to be working with: this guy, and this guy. Right. So the first thing that we need to do is that we're going to need to go to our client VMs, which is this guy, and try to make sure we can access Proxmox GUI from there, from the client servers. And we should be able to, we shouldn't run into any issues there because they are in the same subnet, same network, and all that stuff. So we're going to go ahead and click on that. And the first thing, actually, we need to find the IP address for the Proxmox server. So to do that, we're going to do IPA. And we'll see that the IP address for this guy is right here, which is 10.10.100.50. And then we're going to go to our Windows VM first here. And then we're going to do 10, 10.10.100.50. I'm going to colon 8006. That's the port for Proxmox. And as you can see, we're able to access the server, and it's asking us to log in. And we can go ahead and say root and then use the 10 password. I can remember. And as you can see, we've logged into the server. Now, a couple of things that you're going to notice is that one, of course, this connection is not secure, and that's what we're trying to solve here. And if we go here and take a look at the certificate, we can see that the certificate that's being used is kind of a self-signed certificate from the Proxmox server. And of course, the certificate is not in our trust store on this VM. So it's throwing us an error saying that there is no HTTP, there is no HTTPS connection here, and this connection is not secure. And that's perfectly fine. Now, we should be able to access it on our other client as well with no issue, but let's go ahead and give that a try. And this is our Linux client. And I'm going to say no, scroll down more. Got it. And I'm going to do 10.10.100.50 colon 8006. And there we go. So we're able to access this guy as well over here. So we're good to go on both ends. So we're able to log in here, log in there, and we're able to access this VM. Now, the next thing that we need to do is that when we are going to be setting up let me go back to this VM. When we're going to be setting up our certificate is going to be tied to a domain. And we don't want to be using the IP address to be able to access the server, right? Because if we set up a certificate for a specific domain and we're using an IP address to access the server, that certificate does not apply to the IP address, it applies to the domain. So we'll not be able to access it, or we'll not be able to get that SSL SSL security that we're looking for when it comes to accessing it through an IP address instead of a domain name. So to be able to solve that, first things first, we need to make sure that both of this client VM are looking at our DNS server, because we're going to do a DNS entry and A record for our Proxmox server, right? So we can use an FQDN to be able to access it. And we're going to tie our certificate, of course, to our domain. And then our certificate would apply correctly, and we'll have the SSL and the padlock all looking nice once we have everything set up. And the first thing I we need to do here is we need to make sure that this guy, so this is Windows, so CMD, and then we're going to do NS lookup just to make sure that this server is looking at the right DNS server. So NS look here, and we can see that it's looking at 10.10.100.3, which is perfect because that's the IP address for our DNS server here. And if we go into our Linux client as well, we're going to make sure that it's looking at the correct DNS server. And we're going to do resolve.status, resolve.ctl.status. And yes, it's looking at the IP address for our DNS server. So if we go back up here, DNS server here, we can see that that is our DNS. If we go to network, we can see that that is our IP address for our DNS server 100.3. So now we want to go to our DNS server. We'll go to console. And then we want to do ls here. And then we're looking for our forward lookup zone here. We're looking for this file right here. And we want to add our Proxmox server in this guy right here. All right, so we're going to do nano, and then we're going to do DB, and we're going to do KTech Lab. If you don't understand what this is, I do have a video that I walk through DNS setup, so you can check out that video if you want to have your DNS setup. So once we do that, you can see we already have some A record in here. What we're looking for is we're going to add a new A record. So we're going to call this Proxmox XMOX, and then we're going to call it it's an internet record. It's an A record. All right, and then the IP address for our server is 10.10.100.4. Was it 4 or 5.50? Totally forgot the IP address there. That's 50. So this is the IP address for our server. And now we're saying that we want to be able to access it when we do something like proxmox.ktoechlab.com, because again, the certificate is going to be applied to our domain, right? So you need to be able to enter the A record so you can access the Proxmox server from your clients through your FQDN, because again, I don't mean to sound like a broken record. The certificate is going to be applied to your domain. So in order for it to take effect, essentially, you have to make sure that you're using your FQDN to access your Proxmox server. If that makes sense. So Control X, and then we're going to do Y for save, enter, and then if we do cat here, just to make sure it's in there, cat lock is on, CAT, and we can see that it's perfectly fine. It's in there. Now, if I try to ping it, it's going to fail because we need to restart the bind server first before we can ping it. So if I try to ping ng oxmox dot ktoechlab.com, it's going to fail because it's going to tell you that there's no KTech lab in that config file, right? Well, it's saying that there's no KTech lab in the current config file that it can see, but once we restart it, should be able to update the config file and be able to see this guy in there. So to do that, we're going to do system STEMCTL restart bind 9. Okay, so now we're going to go back and run that command, and as you can see, we're able to ping it. So now, ideally, if we go back to any of our client VM, because our client VMs are looking at, let me go back here. Our client VM are looking at this DNS server, right? So this and this are looking at this as the DNS server. They should be able to access it, or should be able to make sense of the proxmox.ktoechlab name if I was to enter it here, the FQDN here, right? So if it's pre-IOX, mox.klab.com. Don't forget the port number. You need the port number, of course. So it is 8006. And there you go. So now we're able to access our Proxmox server using an FQDN because we've entered that in our DNS server. And again, that is very important because, again, the certificate is going to be applied to this domain. So if you access in Proxmox with its IP instead of the FQDN, the SSL cert is not going to work because that cert only applies to this guy right here. So that's something to keep in mind. So if we were to go to our other client server here and then go to login, I can log in. Hopefully I got the password right. I did, and I do proxmox dot ktechlab.com. Again, I forgot the port. So 808006. And you can see that we're able to access that guy right here. So that's the first thing that we need to make sure that our FQDN is set up and we're accessing Proxmox through our FQDN, through its FQDN instead of the IP address, right? So that's very important because, again, the certs only apply to this domain. Now, the next thing that we need to do is we need to now generate our private key for our Proxmox server. And we also need to generate our CSR. So we can take that CSR and send it to our certificate authority that we set up in our last video. So the certificate authority can sign that CSR and give us a certificate that we can use on our client's VM to be able to set up that secure connection between our server and our clients that we need. So to do that, we're going to need to go to the server, right? There are a lot of commands that I'm going to need to run, some of which are pretty long. So what I'm going to do here is I'm going to SSH into this guy right here. So I'm going to SSH into the Proxmox server because it just allowed me to be able to copy things over. Now, if you don't know how to SSH into your server, I have created a video about it. So you can pause here and then go check out that video and then come back. All right, so I have SSH into this VM. It's just a little bit easier for me to SSH because it allows me to be able to copy and paste things, which is a lot more easier. So the first thing that we need to do is we need to generate the private key. The private key is basically going to allow us to be able to generate the CSR, and the CSR is what we're going to use to send over to our CA to sign, right? So to generate the private key, what we want to do is we want to run this command right here. Now, one of the things that you're going to notice is that I'm going to be using OpenSSL a lot. And then that's because OpenSSL is kind of like the foundational tool that's used on the back end to manage most PKI operations. And a lot of the other tools that you see, like let's say Step C and all those other tools, are basically just kind of a wrapper around OpenSSL to be able to manage things better and make things a little bit better. They do more than that, of course, but that's kind of gives you a basic idea of OpenSSL being the godfather of kind of like this PKI management on the back end. So basically, what we're doing here is that one, we're calling OpenSSL, right? And then we're saying generate a private key for us. And then we're telling it what we want to call the private key. And then we're telling it what the key length should be right here. So once we click enter, that should generate our private key for us, right? It takes a couple of seconds. And if we do ls, you can see that now we have our private key here. Again, private key, super secret, super secure, or you should keep it super secure. And the only reason why I'm generating here on in this location here is because I'm demoing. But normally, when you do something like this, you want to make sure your private key is super secure. You want to kind of put it in a location where it's not easily accessible and be very protective of your private key, right? So just really, really try to protect your private key. Anyways, so now we have the private key. The next thing that we need to do is that we need to kind of generate our CSR. Now, one of the things to keep in mind is that the private key is the private key already contain everything you need to create the public key. So in essence, the private key kind of holds the public key inside of it. So it contains everything you need to create the public key. And when we generate a CSR, it simply just pulls the public key from the private key and then include that in the CSR certificate signing request, along with the server information that we're going to use to be able to send to our server and have our send to our CA server, certificate authority server, and have our CA server sign it and then give us a certificate, right? So that's one thing to keep in mind. You don't see the public key here. That's because the public key is already contained in the private key. Just want to kind of clarify that a little bit before we move on. So now that we have our private key, right? So now we're able to use our private key to generate our CSR. But in order for us to generate our CSR, we want to create a config file. And that config file is going to hold all of the things that we want to apply to our CSR. So it's basically going to allow us to be able to use that config file and generate our CSR. And the reason for that is because it makes it a little bit easy to have all of your config or all of the changes, all the things that you want to include in your CSR in a file. And then when you run in the command, you just point it to the file. And then the command just looks at the file and then say like, okay, these are all the things that you want to include in there. And they go ahead and then generate the CSR. So we're going to go ahead and create that file. And we're going to say nano, and then we're going to call it ktech lab.wildcard.cnf. All right. So we're going to say, we're going to call it ktechlab.wildcard.cnf because this is a wildcard set that we're creating, and this is the config file for the wildcard set. And I'm going to click enter. And I already have the thing here, so I'm just going to copy it and paste this so it's a little bit easy. And I will include this on my website too if you guys do want to see it or you want to just copy and paste. Starting from the top, we have the require. So these are kind of the required field that we need to enter or is needed to be able to generate the CSR. So on the top, we have the default bytes. So we have the RSA key here, and the RSA key is currently set at 2048. And then prompt, we're basically saying no, just use this config file. We're saying do not prompt, use this config file to be able to generate the CSR. And then you have the default MD, which is basically just setting the hash algorithm. And then you have the require extension here, which is basically just pointing it to this guy right here, which is basically pointing to the subject alternative name. And we'll talk about that in a few. And then here you have the distinguished name, which is the DN. And that's pretty much it for the require section. And then the DN, of course, again, DN is pointing to DN here. And then the require extension here is pointing basically to this guy. So it's basically telling it to point to this guy, right? So the DN is the distinguished name. And of course, this is the C name. And again, this is our FQDN. This is our domain. So we're doing a wildcard to say that like any subdomain in this domain should be fine in regards to the certificate, right? So the certificate should basically work for any um, domain in any subdomain in our domain, right? And this is why it was important for us to set up our FQDN for our server, because we're going to set up the certificate for this domain. And in order for the certificate to work, we need to access our server through our FQDN using this domain. So proxmox.ktechlab.com. That's a CNAME. And then here you have the required section, which is a subject alternative name. And this guy is basically just pointing to this guy. So the subject alternative name is what we talked about earlier. This is where you can add or some of the other services or other servers that you want the certificates to be applied to. There are a couple of things that you can do here. Let's say you generate a certificate for just one specific server and you call it here, say like vault.ktechlab.com. And you're like, you know what? I want that certificate to apply to other servers as well. You can include that in here. Not really the best way to do things, or you would do something like this where, hey, I want a wildcard certificate. The CNAME is a wildcard certificate. However, I want this certificate to only be applied to specific servers. This is where you would do it. Now, one of the things to keep in mind is that when you push this to your server, once the certificate is generated and you push this to your server, to your clients, the clients normally ignore the CNAME and they look in here to be able to see what exactly is in the subject alternative name and what servers or services exactly is this certificate applied to. So if you want to do something where like, okay, you know what, I want to generate a wildcard certificate, but I want it only to be applied to the servers, you would do something like, let's just copy this, for example. I'm going to copy that and I'm going to move down here, and then I'm going to paste that in. And then you would do something like, let's say, vote, AULT, vote.ktechlab.com, and then you will call this proxmox.ktechlab.com. So now, if you were to, once you generate the certificate, if you were to navigate or go to vote.ktechlab.com, that certificate will work just fine as long as that's stuff that's been presented. It will work just fine. However, if you were to go to something like, let's say, media.ktechlab.com, because that is not included in here, of course, you wouldn't have this in here, right? Because this means that it applies to all subdomain, right? So if you don't have this in here and you have something like media.ktechlab.com, or you have something like proxmox.ktechlab.com, then you go to media.ktechlab.com, you will receive an error because that is not in the subject alternative name. So that's a good way to kind of lock things down a little bit where it's like, hey, if you're working in a restricted environment, you say like, hey, I don't want to generate a certificate for every single server or every single service wherein every single subdomain in this domain can use the certificate. I only want the certificate to apply to specific servers and services. This is where you will make that change and say like, hey, generate this guy here, put the CNAME as a wildcard, but only add the services that you want the search to apply to. I hope that makes sense. In my case, again, I want a wild card, so I'm going to get rid of that. But in your case, it might be different. And the downside to this is that if you were to set up something like that, the downside to it is, like I said earlier, every time you add a new service, every time you set up a new server, and you want to apply your certificate to that server, you have to come in here, add a new server, generate a new CSR, generate a new certificate, and then re-push that certificate to your servers to your client servers or your client computers that are going to be accessing your server for it to work. Because if you don't, then it's not in the subject alternative name. You will receive an error. Okay, so yeah, I'm gonna get off. I'm gonna get off my soapbox for today. I think that's what it's called. Okay, so to save, Control X, go Y, and then enter. And now we have our config file, and we have our private key. So now we are able to generate our CSR, certificate signing request. So to do that, we're going to run this command right here. So basically, again, we're going to be using OpenSSL, and we're using the private key that we generated, and we're telling it basically to call our CSR file .csr, ktechlab.wildcard.csr, and then point to this config file that we generated to say like, hey, this is the file that I want you to look at to be able to find all the information that you would need to be able to generate the CSR. So if I click enter, if everything is set up correctly, there's no error in the config file, it should be able to generate the CSR just fine. Okay, so that looks like it's working. So I'm going to do ls. So now as you can see, we have our CSR right here. Now that we have our private key and CSR, we can go ahead and transfer that CSR over to our certificate authority to have it signed. So far, what the server has done is package a request, the CSR, and that CSR basically just says, here's my public key, here's my domain name and organization, and here's a digital signature proving I own the private key that's matching the public key in my CSR. The CS job is to act as a trusted witness. So basically all it's doing is verifying the information and sign the certificate if everything checks out. That signed certificate is what the clients will later use to trust the server. So the CA is basically the authority that is going to vouch for the server. Let's go ahead and let's have the certificate authority sign the CSR. So what we've done so far is we have generated our private key. Of course, we've set up the DNS part of things as well, but we've generated our private key. We've generated our CSR. The CSR basically contained the public key and it contained the information about the server. Now we're basically going to take this package that we've set up, which is the CSR file, and we're going to take it over to our CA and we're going to ask our CA to say like, hey, look, I have this information, which have my public key, which in a way in there somewhere you can see that I own the private key to this public key. Can you please sign this for me to bear witness to say that like, hey, this server really owns this private key? So that's basically all this the CA is going to do. But in it, for us to be able to do that, of course, we have to copy this over. And to copy this over, there's two ways that you can do it. The first way is that you can do something like nano, and then you do ktag lab.csr here. Right. And then you just copy this over. And this information here, or whatever the information that you see here, it just, your CSR doesn't contain your private key. It only contains your public key and basically some information about your server. So someone seeing it doesn't really mean anything. It's like someone seeing your public key. Your public key is meant to be public and people will see it. So you don't have to worry about that. So you can just copy this over, right? And then go to your CA server, create a new file, and then paste this in. Just be careful, no space, no nothing, because normally like the CA server or any certificate things don't really like it when there's space and things like that in there. So that's one way that you can do it. The other way that you can do it is you can use the SCP command. The SCP command basically just allow you to be able to copy things to another server over the network. Now, there's a couple of things to keep in mind. One, with the SCP server, SSH needs to be enabled on the server that you're trying to copy things over to. Right. So you need to either use password based authentication or you're going to need to use a key based authentication. Right. One of those two. Again, if you don't know about SSH, I have a video, go check it out. Right. So, but SSH needs to be enabled for us to be able to copy things over, right, using the SCP command. And to do that, we're just going to run this command right here. So I'm actually going to clear that so it's a little bit clean and then rerun that. So we're going to run this command right here. I kind of click enter when I enter myself. So we're going to do SCP, right? And we're telling you that we want to copy this file over, right? This is our CSR. And we're telling you that we want to copy this over to our CA server. The IP address for our CA server is 10.10.100.4. And then I'm using password-based authentication, and then I'm using root as the user. And then I'm telling it to copy it over directly into the home folder of the root user. Right. Again, you see me doing a lot of things with root user here, but again, keep in mind that when you're in an environment that needs to be secure, again, this is my test environment. I don't want to sound like a broken record all the time, but a lot of things that have to do with security, I'm a bit lax on it, and it's not the ideal way to do things. Just make sure that when you're copying things over, when you're doing things, just kind of make sure you're a lot more secure, right? But in my case, for demo purposes, kind of using things like that. So just keep that in mind. But anyways, so yeah, so we're copying this over. We're copying this guy. We're copying it as the root user, and we're copying it over to our home folder, and we're basically placing it in this guy right here. So now it's asking us, what is the password for the root user on this server, on our CA server? We're going to enter that password, and hopefully I got it right. All right, and then I'm going to click enter. And as you can see, it's telling us that like, hey, okay, I just copy this file over, 100% is done, and it just basically give us the information about the file. So now what we're going to do is we're going to go over to our CA server and we're going to see if we're able to see that file over there. Now that we're back in Proxmox, we're going to go to our certificate authority here. Again, if you don't know what a certificate authority is or you're not aware of anything, please take the time to go watch the previous video because that's where we set up our certificate authority because that's very important before watching this video. You're going to need that before you be able to sign the certificate, the CSR, the certificate signing request that we just generated. All right, so that's important. So here, what we're going to do is this is the CA server that we copy things over. So we do a pwd. We're going to see that we're in the home folder for the root user. So if we do ls, we can see that that file was copied over. So that's perfect. Now, what we want to do is we want to use our CA to sign the certificate signing request so it can give us a certificate that we can use. All right, so our CA should be up and running, and we can check that by saying, stmctl status step dash CA. Yeah, and then we can see that our certificate authority is up and running. All the service for our certificate authority is up and running. So we're going to do step CA SIGN, and then we're going to do KT, and then we're going to do KT again, and then we're going to say CRT. So basically what we're telling it here is that, hey, one step CA to sign or look at the CSR and be able to sign the CSR and then give us a certificate that is called KTech Lab Wildcard.crt, right? So that's basically what we're doing. So if we click enter, if everything is working, it should ask us for a provisional password, and we'll enter that, and then it's going to sign it. So I'm going to go ahead and click enter. And as you can see, it's going to ask us for our password. Now, this password is what we created when we were setting up steps here. So that's very important. Again, if you don't, if you haven't watched that video, take the time, go back and watch that video before you come to this video, before you watch this video, because that's kind of very important. All right, not kind of, it is very important. So here we want to provide the password that we set for our provisional when we set this guy up. So in my case, I'm just going to put that guy in, and even if you're typing in, it's not showing, that's perfectly fine. It doesn't show when you type. So you're going to click enter, and it's going to do its thing. So as you can see, it says, yes, this has been signed, and this is the certificate authority that signed it, and then the certificate that it output was this guy. So now if we do this and we do ls, we're going to see now that we have our CRT, our certificate right there, and we're able to now use this certificate to be able to push to our server and our clients. There are a few things that you can check here before you start sending a certificate over to your server and your clients and things like that, or start pushing the certificate down to your clients and all the other things that need it. So we can do something like, let's do ls one more time. So we can do nano, and then we'll do ktech lab.crt. And as you can see here, the first one is normally our wildcard set that we just generated. And then here it has the intermediate cert, because the intermediate cert is what signed the server cert, right? So we have the intermediate cert, and we have the wildcard set that we just generated. And then normally begin and end max the beginning and the end of one cert, and then begin and end max the beginning and end of the other cert. So if I click X here, right? Another thing that we can do as well is we can check the content of the site of the cert. So we can run a command like this, for example, to tell it to kind of give us some information about the cert. So again, we're using OpenSSL and X509 and the certificate type here. And then we have the KTech Lab CRT. We don't want to CSR, CRT here. And then we're just going to click enter. So that's going to give us all of the information about our certificate here. So who signed our certificate, our CNAME, which is our certificate. And it tells it when the certificate is expired. So as you can see, this is kind of like, it's going to last for like a few hours or one day, I guess. But because when you just set up Step CA, it only issues a certificate for, I think, 24 hours or so. There's a config that you can go into the config file to be able to show it, to be able to change it. So it lasts for about a year or however long you want it to last. And it gives you all of the rest of the information that you need about your cert. So that's one thing to do as well. And also, if you want, what you can do, if you want to check the date as to when your certificate is going to expire, you could do something like this guy. So similar, but again, just a little bit different. You just do date, CRT instead of text, right? And it tells you, it just pulls the date information from that cert, and it tells you that, hey, this cert is going to expire at this time. And again, something to keep in mind, right? Because this certificate lasts for this long. You can go to the steps here config folder to be able to make changes to that, right? Because if you're going to use this in your environment, you don't want it to be issuing certificate for like 24 hours or a day or so, because the problem with that is that it's not automatic. If you have some sort of automatic process where it requests certificate every 24 hours for security reason, that is perfectly fine. But if you don't want that, you can make that changes. And I think you should be able to do that. And I think you should be able to do that in this config right here. So cd, I will include the config changes in my blog. So if you do want to see what needs to be changed, just check out the blog. I'll include that in the write up. So cd, what is it, roots, and then that s, what is it, that's ca, is it step ca? Yep, steps. Enter ls, cd config, enter, and you should see the information that you need in here. So in here, there's some key and information in here, but in here, I'm not going to display it here, but in here, you can see the config file that show the you can make changes to this file in here for it to be able to issue a certificate for a longer period of time. Again, I'm going to include that in my blog. I'm going to include that in the write up on the blog. So check it out if you want to make sure your certificate lasted a little bit longer. In my case, I'm not so worried about it because again, this is a test and this is going to be reconfigured. But this is where you would change that config to apply. So every time you generate certificate. I think you can do it also with a command, but this is the best way to do it so you don't have to worry too much about it. And again, I'll include this in my write-up. So now we are pretty much good to go. We have our certificate, and now we're ready to take the certificate, send it to our servers, and then set things up on the server, because now we need to take this over to this server and configure Proxmox so Proxmox can use the certificate and present it when clients are trying to reach out to it. All right, so now, well, we have our certificate and it's been signed by a trusted certificate authority. This certificate is what needs to be made available to client so they can establish a trusted and secure communication with our server. Now, a couple of things to keep in mind is that when we're installing a certificate on the client side, it is best to include the full certificate chain. So this means the root certificate, the intermediate certificate, and the server certificate so that the client can properly verify the trust path. There are two ways that you can do this. First, you can install a certificate directly on the client application that will communicate with the server. For example, in your browser. Second, you can install it at the system level on the client's machine, meaning the whole operating system trusts the certificate. Installing it at the system level is usually the better option, especially for environment with multiple apps and services on that client machine. That way, all applications or all your application on the system will trust the certificate and you won't have to configure each one individually. That also depends on what you're setting up, right? So you have to kind of figure out what you want to set up and see if you want to set it up at the system level or you want to set it up directly on the application that's going to be communicating with your server. With that being said, let's go ahead and let's take a look at how to do that. All right, so the next thing that we need to do is we need to update our Proxmox server, this guy right here, so that when someone try to access the Proxmox server through its FQDN, it's presenting the right certificate. So right now, if we were to go into one of our clients, our Windows client here, and we click on our server, we click on our certificate here, we can see that the certificate that's being presented, if we go to detail, you can see that the certificate that's being presented right now is the self-signed certificate that was originally created when you set up Proxmox. And that's not the certificate that we want to be presented when you try to access the FQDN of the Proxmox server, the GUI of the Proxmox server. We want the certificate that we created, the certificate that we set up, our wildcard certificate, to be the certificate that's presented when you try to access the Proxmox server. And to be able to do that, what we need to do is we need to go back to our CA server. So there are a few things that we want to copy over. We definitely want to copy this guy over. This is the wildcard certificate that we generated, right? When we have our step CA or certificate authority sign our CSR. We're definitely going to need to grab this guy. And the other thing that we're going to need as well is the key. So let me clear that, do ls here. We're going to need this key as well. So those are the two things that we're going to need. The key is already on the Proxmox server. So I'm going to go ahead and copy over the certificate, the wildcard certificate, ls one more time. And I'm going to do SCP. I'm going to use SCP. So I'm going to do root. and I'm going to put it in the root as well. So I'm going to click enter, and I'm going to enter the password. Okay, and then that has been copied over. So now if I go back to the Proxmox server, all right, I'm going to do that. I'm going to do ls, and we have cert, and we have the key. So those are the two things that we need to copy over. Now, there are two ways that you can push these two things, the cert and the key, to Proxmox, right? So Proxmox can present that when someone tries to access the GUI or try to visit Proxmox. The first way is that you can do it through CLI. And then the second way is you can do it through the GUI, the GUI. Now, I'm going to do things through the GUI because it's just a lot more simpler, easier for a lot of people to understand. But I will include the way to do it through the CLI on the write up. So if you do want to check that out, go check out the blog, and that will be there as well. Right. So, but for now, we're going to do it through the CLI. Now, what you want to do is you want to copy the information on this and this guy over. You're going to need that. So for the wildcard certificate, for example, you can do something like nano ktech.crt, right? And then what you want to do is you want to copy this whole thing here, right? So you want to copy from here where it says begin certificate all the way where it says end, because remember the two certificate in here. You have your intermediate certificate, you have the wildcard certificate and the intermediate certificate in this guy, right? So you can copy both of this over because you need the chain, right? And then if we go back here, Control X, LS, and then you want to do the same thing for your private key. I'm not going to display my private key, of course, even though this is a demo environment. Still, I'm not going to display it because it's a private key. But you want to copy it over, copy the private key over the same way you will copy this guy over as well. So I have done that already. I have kind of transferred that data over to a share file on my server here, on my server here, on the VM that I'm using, the test VM that I'm using, the client VM that I'm using here to kind of demo the whole thing. So I'm going to go ahead and just copy the private key. Again, pretty straightforward, right? So you go back here, you do nano, right? You do nano, and then you just copy this, and then you're going to paste it in, and then you're going to do the same thing for um, let me go back here. Ls, you're going to do the same thing for your private key. So we're going to go ahead and paste in our private key again. Keep in mind that your private key is private, right? And should not share it with anyone. I'm going to keep saying that forever. Again, my environment is a test environment. I'm going to go ahead and paste in the private key. So once you paste in the private key, it's going to look something like that. You're going to have the end private key. And of course, you just scroll up a little bit more. You will see something that says the top. I'm not going to scroll up because I don't want to show all of it. Again, one more time, private key always stays private. The reason why I'm even showing part of it here is for me, this is a test environment. I might even actually grade out the little bit that I'm showing here. The next one that we want to grab is that we want to, if I go back in here and I do ls, is that we want to grab now our certificate chain. So like the one that we created, the wildcard certificate, I want to go ahead and grab that. And I've copied that over. We'll go over here and we'll go ahead and click on our wildcard certificate here. This is the certificate that we need to copy over. So I'm going to select all, and then I'm just going to copy. And then this is exactly the same. So if I go back to the Proxmox server here and I was to do, let's do ls and do cat, ktech, crt, right? This is this guy that we'll copy. We're basically just copying this guy over. So I'm going to go back to that guy, and then I'm going to already copy it. I'm going to go ahead and paste it in this guy. So now we have our private key, and then we have our certificate chain here, which includes, again, our wildcard certificate and our intermediate certificate, right? So we're going to go ahead and say upload, and then Proxmox is going to upload that certificate for us. All right, so you might need to give it a few, and you might even need to refresh this guy. All right, so let it load. All right, so perfect. So it works the way it's supposed to work. Now you can see that we're receiving a new SSL error, right? And that's because the certificate that's being presented now for going here is our certificate. So now, as you can see, our certificate is being presented, and our computer is basically trying to recheck things to see and say, like, hey, I'm not able to verify the certificate because I don't have the root CA in here that pretty much signed this guy right here. As I said earlier, there's two ways that we can solve that issue. One, we can solve that issue by importing our root certificate directly into the client the application and the clients is actually going to do the communication with the server, in this case, the browser. So we can literally import the root certificate into the browser and have the browser kind of go through it and look at it and say like, hey, okay, I can find this in here. I'm able to go back and forth with the server, and we're able to start that secure communication. To do that, we're going to need to grab our root certificate, right? So this is the root certificate that we created when we create our certificate authority. I'm going to go back to our certificate authority here, and I think I'm already in there. But just for clarity, I'm going to go back. I'll do ls. I'm going to cd root step. And this is where all of your certificate, the steps here, config and certificates are located. Well, most of the certificate and other things, right? So I'm going to cd into cert. All right. And if you don't know what this is, again, you might want to go back and watch the steps here video where we create steps here. All right. And then ls. And then as you can see, we have our intermediate certificate and our root certificate in here. We need to import this root certificate to our server. So our server or our client is able to become aware of the certificate that's being presented and saying that like, oh yeah, I have the roots here that signed the certificate that's being presented. So that communication, that three-way handshake can start going on, right? So we're going to start with the roots here. So you can do something like, let's say cat root CA, and that's what it looks like. And I can do, if I go back up here, go there, and let's just do nano. And I could just copy this over, all right, because this is Windows. I'm going to copy this over to my folder and be able to grab it. All right, so I'm going to add and copy that over. So if we go back to our server, we're going to be able to see the root CA file. If I open this guy, I just created a share folder on Windows and be able to copy things over because it's Windows, and I didn't want to go through all the headache of trying to manually copy things over. I can SSH into that VM from here, but just wanted to create a share folder. So that's where you see this here. I'm just copying things over to the share folder. Okay. So if we look at the certificates that are already installed on this guy here, so we're going to do something like run. Let's click on this and then do MMC. All right. And then click yes, Microsoft Management Console. And it's going to pull up this guy, and we're going to say file, add and remove snapping. We want to see the certificate. We're going to add that. I'm going to say for the computer, click next. It's perfectly fine. Finish, and then click OK. So if we go certificate, we'll go to trusted root certificate. Of course, that certificate is not in there. And that's that's the main reason why you get in the SSL error, because the certificate that's being presented, right? If we remember when we talk about the three-way handshake, the certificate that's being presented is Koroma Tech or K-Tech Intermediate CA. And then of course you have the server CA. But the problem is that this guy right here, the root CA is not in here. So when the computer checks the 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 trust store, the root CA is not included in here. So the computer is saying that like, well, I don't trust this guy because I don't have anybody in here that can vouch for the certificate is being that the server is presenting. I don't have any root CA in here that's vouching for the certificate. So please don't trust this guy, and I'm going to give you a warning. That's basically what's happening. But what we can do is we can do it on the browser level, or we can do it on the OS level. So we're going to leave the OS level for a few, and then we're going to try to do it on the browser level. For the browser, we're going to go here, and then we're going to go to settings, more. There you go. Settings. I just have to scroll down a little bit. And then I'm going to do RT, click search, and it's going to give us the result here. And what we're looking for is security. And then we want to scroll down a little bit. And then you want to say manage certificates, right? And do that. And then you're going to see a couple of things here. You're going to see your certificate. You're going to see local certificate installed by you. So this is a certificate that you installed. So once you click on that, let me go back here one more time. You're going to scroll down here. You're going to say install certificate. Now the server is telling, the client is telling you. So this is not the whole server. This is just the client. So this is sort of what we're talking about where you say, where I was saying that you can set up the certificate so that the root CA is set up on the clients that's directly communicating with the server, or you can set up the certificate where the root CA is installed on the server itself. So any other client that is trying to communicate with that server, they will check the Windows certificate store. And if that certificate is in a trusted store, then um, the root CA is in the trusted store, then the client would trust the certificate that's being presented by the server. I hope that makes sense. You have the different type of certificates that you can install here. What we're looking for basically right now, we can input the intermediate certificate, but there's no need to right now. We want to input the root certificate. So if I click import, one of the things that you're going to have to do is first, we're going to need to change the extension for that certificate, right? So if we go, where is that guy? Go in here. It's not going to see it because it's not .crt. And if I click all file, you'll be able to see it there. But it, if I try to import this, it most likely fail because it has a CRT. Probably not. So let's give it a try. And oh, okay, perfect. So it didn't fail. So you can click on import. Normally, you will have to change it to CRT. If you install it, and we're going to see that in a minute. When you install it on a Windows computer on the Trust Store in MMC, you will have to kind of install it as a CRT. You can add that in there too with just the text, but it's cleaner when you just change the extension to CRT. And I'll show you guys that in a minute. But there you go. So now the root CA has been added on the client itself, right? So now ideally, if we were to kind of get out and get back in, right? So let me copy this, completely close this guy, get back in, and then try to paste this guy in. Right. So now we're completely on 100% secure. As you can see, this connection is 100% secure. And the reason for that is because, again, if we now go to our certificate here, secure connection is secure tab here and click on it and then go to certificate is valid. Now you can see that our root CA is there. So our client is saying like, oh yeah, I have a root CA that signed the intermediate CA, which signed the server CA. And that's the chain of trust that we were talking about earlier. Now you see the whole chain of trust. And because the root CA is in here, and this is what I was saying, that if you were to only have the intermediate CA in here, you can see that the certificate is not trusted. But when you have the root CA in there, because the root CA is the ultimate source of truth, now the certificate is 100% trusted. And as you can see, if we go back in here, the connection is now secure and we can log in. So we can go to root and then we can go to enter our password here. If I type it right, I don't think I ever remember my password. All right. So I got it right. So never. And then as you can see, our connection is now 100% secure. And that's because our server is presenting our certificate and then our root CA is included in the client. And the client is saying like, yeah, I trust you and I'm able to present it. And that's how you do it on the client side. Now, if we were to say like, okay, well, we don't want to do it on the client side, we want to do it on the server side. What we need to do is we can go back down here, go to settings, let it load, do a search, right? And then go back to security here, scroll down, manage certificates by me, and then we can remove this and then click OK. And now if we were to get out, get back in and type in Proxmox, enter, it's going to start giving us the error again because, again, that root CA is not there. But now we want to say like, hey, we don't want to do it on the client level anymore. We want to do it at the server level. So we're going to go ahead and import our root certificate into our server. Now, we can import it like this. We can double click it and then just copy this guy right here and import it. Or what we can do, if we go to view here, and go to show, and we just want to see the extension. We want to, first of all, I'm going to copy this guy over. Actually, before I do, I want to rename it. We just want to rename this to CRT. That's basically telling Windows that this is a certificate and it's going to treat it accordingly. So if I click enter, it's going to ask you, do you want to change it? Yes. And you're going to see it change to certificate here. I'm going to go ahead and copy this out so I can paste it here and paste. And then I'm going to run it. This is the easiest way to do it because then once you click on it, Windows is going to go ahead and then just go through the installation for you. So it's telling you that that's not trusted. That's fine. We're going to go ahead and say install. And then we're going to say local machine. Try not to do current user because that's only for your user account. Click next. It's going to say yes. and then it's going to ask you where do you want to place this. You can have it automatically be placed. Automatically be placed. Windows will figure out where it needs to go in and put it there, or you can do select your store, and then you say you want to put it on the trusted root certificate authority. Click on OK, and then click on next, and then click on finish. And that's going to go ahead and add it. Once you see successful, it's going to go ahead and add it to the roots here. So now if we go back to our certificate snap in here, we're going to need to refresh. I'm just going to make this a little bit bigger. Right click here and then click refresh. Now we should be able to see, there you go. Now we have our roots here right in here. And that guy is now going to be used to trust the certificate that our our server is presenting. So if we go back, remember remove the certificate from the server on the client meaning and the browser. So if we go back there and then just do Proxmox here, and then just click on this guy. No, I do not need that. As you can see, it's now trusted. And if we go to secure, go to certificate is valid, you can see that that certificate is valid and good to go. And if we were to go to cert one more time, just to double check, just so we know that, see that it's not in there, go in here, CRT, and then go to security, scroll down, manage certificates. And as you can see, there's no certificate installed. And Chrome is looking directly on the Windows Trust Store. And because the root CA is in the Trust Store, Chrome is able to say like, okay, cool. I have a certificate authority in here that vouch for the certificate that is being presented by the server, and that secure communication is established. So for the Linux server, which is Pop! OS, I have copied over, I'm going to do ls here. I have copied over the root CA just like I did for the Windows server. So all I did basically same concept, same process. You're gonna go to the CA here, and then you're gonna run this command. Except now it's copying over to my test client server here, and it copied it over to the home admin folder. And if we go back to our client, which is Pop! OS, and do ls, we can see that that's there now, like there. So the next thing I wanted to do is I do want to create like a text document for this. I'm going to cd into desktop real quick. All right. And I'm going to do, actually, let's cd dot dot ls one more time. And I'm going to do nano root. And I'm going to copy this guy because I need to copy it. Copy, Control X. And now I'm going to cd into desktop. All right. ls, and I'm going to touch, and I'm going to say roots.crt. Perfect. And then I'm going to do ls, and then I'm going to do nano root. Okay. And then I'm going to just paste this guy right here. I'm trying to be lazy. Then Control X. Yes, for saving. Then ls one more time. I'm going to do cat just to see, make sure everything is in there. Okay, it looks perfect. So now what we can do is exactly the same process. Now, one of the things to keep in mind is that if we import, and we will do that, when we import, not if, when we import the root cert to the system trust store, so the VM itself, the server trust store, for some reason, Chrome and Firefox and all this other browser do not look at the system trust store. So you have to import it manually. So even if we were to import the cert right now in the trust store for the server, it will still give us an error because Chrome and all this other clients is where browser clients don't look at the system trust store in Linux. You will have to set up a script or do something for it to be able to push directly. And I'm going to show you guys how to do that same concept for it to be able to push directly to for the CA to be able to be pushed directly to the browser itself. But let's import it and then we can test that, right? So to import your certificate to the system trust store in Linux, or at least for Pop! OS, you would do something like copy it over. So you would do cp and then root ca, and then we're gonna copy it into the user local I think a share and a CA, if I'm not mistaken. There you go. So you're gonna copy that over, copy the CA over to this guy right here, and then we're gonna update it and it's gonna push it into the system's trust store, right? So to do that, we're just going to do enter. Hold on, can I create a regular file user? Sure. So then, oh, okay, I need to do sudo. So I'm gonna get rid of that. Sudo su. Um, all right, and let's try that again. So we're going to do cp. I could have just run it. I could have just put a sudo in front of that command, but that's I just kind of switch user just to make things easier on myself. So cp. Let's try that again. Root user local share ca, and that's it. So now we should be able to copy it over. Perfect. Now we're going to run this command here, update dash ca dash cr tificats. So basically what this is going to do is that it's going to look at that folder that we just move that or copy that root ca into, and it's going to grab that and it's going to push it to the system trust store. So I'm going to click enter. And if everything works, it should tell you that one certificate has been added. Again, it just grab the certificate from the CA certificate folder and grab it and then just push it to the trust store. Like I said earlier, even with us doing that, so I'm going to get out of this, even if with us doing that, if I was to close this guy, go back in here, load, and I try to access Proxmox again, click enter, it's still going to give us an error. And if we look here, you can see that that's the certificate is being presented is the correct certificate. But it's going to give us an error because, again, Chrome and other browser clients check for the certificate directly um, on their stuff, not so much on the system level, right? So that's one thing to keep in mind. So even if we do that, it's still going to fail. So what we want to do is we want to do the same thing that we did for our Windows server. Go to settings. And again, if you have a lot of servers that you have to push this to, you can do something like Ansible. And again, there's a lot of videos coming up about everything that we're going to do step by step. So videos are coming out. But if you want to do that, you can do something like Ansible. You can do a script to be able to push this. So there's a lot of things that you can do. And all of those things, I'm going to get to them, just trying to build the environment one step at a time. And some concepts are kind of new to me too. So as I kind of implement those concepts, I will, of course, kind of, you know, m- make a video about it. All of us are here to learn. So I'm gonna go to settings. Same concept. We're gonna do search, and then we're gonna go to security once this load, and then we're going to scroll down here, and I'm gonna go to manage, and I clicked on the wrong one. Manage search, and then we're going to say install cert, and then we're going to import the cert that we just set up here, which is on our desktop, this guy, and that's why we created this. And we're just going to click on it, we're going to go select, and now you can see our cert is imported. We're going to need to get out and then get back in, and we're going to, once it's back up, we're going to try to go to the site again, and if everything works correctly, the site should now be secure. So perfect. So now, as you can see, the site is 100% secure. If we go there, we can see that our root CA is now recognized, intermediate CA, and then the service CA. So yeah, so that's pretty much how we've gone through the whole process of phase one, right? So phase one is now done. We created our CA. We understand how certificate work. We pushed the CA for ourselves, and we now have a good understanding of how certificate work. Before we wrap things up, I wanted to show you guys some stuff about the subject alternative name so you can see it in the certificate once it's been uploaded on the server. So if we go here to connection is secure, go to valid, certificate is valid, go to detail here. For scroll down here, you will see when I click on this and I click on this guy, so it looks like this. If I click on and expand, you see all of the information that you need for your certificate, your public key, and all this other information. But what I want to show you guys is this guy. So this is the subject alternative name, right? So remember when we were talking about subject alternative name, and the reason why this cert applied to every subdomain in our domain, which is ktechlab.com, is because that is included in here. So if we wanted to restrict that, we'll put all of the FQDN for those servers or services in here, and this certificate will only apply to the things that are in here. So this is where you find your subject alternative name on your certificate once it's been uploaded to the server. And if you want to find all this other information as well, you can find all those information here. And this is public, so you'll find different informations in here that are supposed to be public. So, and here's where you can always export your certificate as well, right? So if you're trying to work on a website or working on with a vendor that you need their certificate to upload it to your, let's say, your application, you can always grab it from here as well and pull it down. But I just wanted to show you guys that so you guys know where the subject alternative name can be found on the certificate when you're looking at it from this perspective. All right, that's it. Well, that is it, guys. We now have our internal CA and we've learned how to generate internal certificate and use them within our environment. But I know what you're thinking. Why is there a phase 2? Well, here's the thing. When we say internal CA, that internal part is key. It means that only systems you manually configure to trust your CA will recognize it as a valid source. In other words, your internal CA is only trusted by what you explicitly push it to. And that is limited mostly to your internal network. But what if you don't want that? What if you want to use a publicly trusted certificate and still keep things internal? Well, that, my friends, that is where phase 2 comes into play. Public certificates like the ones from Let's Encrypt are already pre-installed and trusted by most clients and systems. That means you don't have to manually distribute your CA to every device. So in phase 2, we're going to talk about how to get a public certificate while still keeping your service private and internal. As always, thank you guys for watching. I really do appreciate it. Please like, comment, and subscribe. If you do like the video, stay geeking, stay curious, and I'll see you guys on the next one. Peace.